Today we're going to look at graphing quadratic functions. This is actually, this little chart right here I got out of the purple book from last year in the section that talks about polynomial functions. Now the quadratic function is a polynomial function also. It's right here. It's when it has a degree of 2, which is why that squared is right there. And it normally has 3 terms, an x squared term, an x term, and a constant term. This could be absent of the x term and the constant term and still be considered quadratic as long as the x has the squared on it. Anyways, don't write all that stuff. This is probably more important right here, these guys right here. Now this is polynomial standard form. Back in the day in some of the algebra books, they were calling this standard form for quadratic functions. And they were calling this one right here Vertex Form. The reason why they call this one Vertex Form is because the h and the k are your vertex. HK, it would be HK. That would be your vertex here. Okay, that's why they call it Vertex Form. But it is the standard form for quadratic functions, which is why your book calls it the standard form for quadratic function. Anyways, you guys can still write it. It'll still be up here, but I want to go over here to a picture. On this picture, we have two different types of quadratic functions, the ones that open up and the ones that open down. There's your function right there, the little formula thing that some of you guys were copying earlier, in standard form. Okay. Notice that it says right, where does it say it? It says it right here. A is greater than 0. When A is greater than 0, then you know that opens up. When A is less than 0, then you know it opens down. All this stuff is fine and dandy, but until you see the practical, actually graphing it yourself, I feel like you don't fully understand it. So pause it if you want to keep looking at that. Otherwise, we're going to go on to our first example. Now for our first example, we're just asked to graph this. And it's as simple as this. You need to find the vertex, find the intercepts, draw your line. Okay? So it's kind of like 3 steps, but the first 2 are the ones that where you have all the work. So let's draw our x and y axes, or our x and our f of x axis, and get busy. Okay, so the first thing I said we have to find is our vertex. And so for our vertex, since it's in the standard form, we can see it. It's obvious. What is it? 3, positive 8. How come the 3 is positive when it says minus right here? Yeah. You can think of it 2 ways. You can think of it as, oh, the formula has a minus there, so you have to think the opposite. Or you can think of, you guys remember translations when you guys are moving the things around? When it says minus in here, it's really plus, right? Yep. Okay, and that's why. Because the common function for this is y equals x squared. And if you have y equals x minus 3 squared, then you know that it was shifted to the right. So that's why it's a positive 3. Okay, so we can graph our vertex. Our vertex is going to be at 3, 8. So we're going 1, 2, 3 right there. And then 8 is 1, 2, 3, 4, 5, 6, 7, 8. So we have a point right there. That's 3, 8. Okay, and then the other thing I said we have to find are our intercepts. Let's find our intercepts. Which one do you guys want to find first, the x or the y? X, okay. The x is normally the one that requires more work. So to find our x-intercepts, what we're going to have to do is plug 0 into y. So we're going to plug 0 into y, and because it's standard form, we're all like, yay, no factoring, and so we're just going to get busy on it. So we subtract 8 from both sides. That's going to be the first thing that you want to take care of. Because if you divide by 2, you're also going to divide this by 2. And in this case, it would work out quite nicely, but you can't divide 0 by 2, so it might mess you up. After you subtract 8, you have negative 2 times x minus 3 squared. We want to get rid of this squared eventually, but first we got to get rid of this negative 2. So we divide by negative 2, divide by negative 2, we get positive 4. Positive 4 equals x minus 3 squared. Then, to get rid of the squared, we have to square root it. So we square root both sides, and when you square root inside of an equation, what do you have to have? Yes, the square root of 4 is 2, but it's plus or minus 2. Why is it plus or minus 2? Because if you look at something like this that says x squared equals 25, there's 2 different numbers that you could plug into x. You can plug in a positive 5, you can plug in a negative 5. So whenever you do a square root inside of an equation, make sure you do plus or minus. That means you're going to have to solve this equation twice. You have to solve it with a positive 2, and you're going to have to solve it with a negative 2. That equals x minus 3. I add 3 to both sides, I get x equals 5, and over here I get x equals 1. Those are our x-intercepts. 1 and 5. 3, 4, 5. Now let's finish finding our intercepts. After we find our 2 x-intercepts, which we have right here as 1 and 5, we have to find our y-intercept. Now how do we find our y-intercept? Yeah, and that was great. So to find our y-intercept, we want to plug 0 into x. So we have y equals -2. We're going to plug the 0 into the 3 or into the x, square it, and then add 8. So that's going to be -3. -3 squared is 9. Let's clean it up a little bit to make sure that you guys are following me. It's a positive 9 because we, negative times negative is a positive. And then we had 18. No, that's supposed to be -2. So it's good negative 18, and then that equals what? -10. So -10 is our y-intercept here. I go over to my graph, go down to -10. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now I can do my graph. I got my intercepts, I got my vertex, and you'll be surprised. There's a lot of functions that we're going to work on this year where it is horrible. I'm sorry. It's pretty bad. There's a lot of graphs that we will work on this year. Guys, if you just find the intercepts, you'll be good. You get a great idea of what this graph looks like. And now you can double check it too. This graph opens up downwards, right?
Yes.
Which means there should be a negative in front of the highest degree number, right? And we look right here, there's a -2 right there. That means we did everything right. Yay. So now, there's one situation that will come up when you're graphing that I don't want you guys to freak out about. I want you guys to understand. Let's see here. Let's say, okay, do you guys know the vertex here?
-3, 1.
So our vertex is -3 and 1. So when I go to -3 and 1, you guys should notice something. -3, 1. Are there going to be any x-intercepts for this one?
No.
Is it going to open up downwards or open up upwards? It is. Why? How do we know that? Because the A is positive. So what if you weren't paying attention to that and you didn't know? What would it look like? What would happen? This is what would happen. So if you were looking for x-intercepts and you didn't realize, oh, there's not going to be x-intercepts, what's going to happen? You plug 0 into the y and you go to solve it by subtracting 1. And now we have x plus 3 squared, and we square root both sides. Oh, we got a square root of a negative number. That's going to be 1i, right? Imaginary. You kids, you can't take the square root of a negative number. If you have that, then you know that there's no x-intercepts on this graph. Why? Because it's not an imaginary graph. This is a real graph. It's not the fake one. All right. So then what you would do here is you don't need the x-intercepts, but at least find the y-intercept too. You can find the y-intercept just by plugging in 0 to the x. And so we have y equals 0 plus 3. We get a 3 right here. We're going to square it. That's 9 plus 1, which is 10. Now I have a question. There's times when we don't have an x-intercept, but will we ever not have a y-intercept for a quadratic function? The answer to that question is yes, because when you think about the domain for a quadratic function, the domain, that's the x-axis, you can plug in any x number, right? That means you'll always plug in a 0. And that means you'll always get a y value. So here it's 10, and we would graph it 1, 2, 3, 4, 6, 7, 8, 9, 10. And you would just roughly graph, do your thing right here. Now you could be a little more exact than what I just did, and you could say, hey look, 1, 2, 3, and that's where my y-intercept is. 1, 2, 3, that's where I should have another 10 right here. So it looks like I did it correctly because it has symmetry.